Alright guys, I'm going to go over 1.4 notes. So the good thing about this is this section is literally the exact same, 100% the same as any other section that we've done, as the last section we just did. The only difference is that this little shortcut that we're using right here, this shortcut, if 1x squared, that doesn't work anymore. So we're gonna have to must guess and check using FOIL. That's the biggest idea here. So must guess and check using FOIL. Order matters. Those are the two things that happened today. That's the really biggest difference. So everything else is exactly the same. So you're always going to start looking for something in common. You're always going to do that first. That's always going to make your life a little bit easier if you do or don't. Like, for example, in example A here, they do have nothing in common. Two of them have a letter, but not all three of them. There isn't a number that goes in all three, so then I would count the number of terms. 1, 2, 3 terms. I would follow these steps right here. All right, that's what we're going to do next. All right, so I already talked about these, about A not having anything in common. So right now, I look for something in common. I said no. So I count the number of terms. So 3 terms. Now the slight difference is, instead of having x and x here, we're going to have 5x and x, because I not only need to be able to get x squared, I also have to be able to get 5. So that's the slight difference that we had before. Now good news is we still only have one choice here. So that means I have to have 5x and x with my parentheses. Now when I go over to 6, remember, it's a positive 6. It could be 1 and 6, or it could be 2 and 3. Or remember, it could be negative 1, negative 6, negative 2, negative 3. Now I actually know that since there's a negative in the middle, it's probably more than likely going to be a negative 1, negative 6, or negative 2, negative 3. So now I have to guess. Now there's actually 4 different options. So there's option A, right? You could have 5x minus 1, x minus 6. You could have option B. You could have, so I'm just writing all the possible combinations of what we have. You could have 5x, but this time you could put the minus 6 with the 5x and the x minus 1. Or you could have option C. You could have 5x minus 2, x minus 3, or you could have option D. So this is a multiple choice problem. I would probably pick one of these. These would be probably your 4 choices. Only one of these works. All right. So only one of these works. I have to check and see which one works. All right. So to do that, now none of these add up to be negative 17 in the middle. None of these add up to be negative 17 in the middle. None of them add up to that. Because negative 1 and negative 6 is negative 7, negative 2, negative 3 is negative 5. Remember, that doesn't work anymore because it is not 1x squared. So to check my work, I actually have to do FOIL. So like I'm going to do the outside. So this is 5x times minus 6 is minus 30x. I'm going to do the inside. That's minus 1x. Together, that's minus 31x for the middle. That is not what I have right here in the... So I know this is not my right answer. So now I try this one. 5x times negative 1. So look, I do the outside. It gives me minus 5x. I do the inside. I get minus 6x. Together, it's a minus 11x. So I check the outside and inside. So all I'm doing right here, this red writing, is just me doing the outside and inside of FOIL to see if it gives me the middle. Right? It doesn't work. So that's automatically wrong. Now I do this one. 5x minus 3, I get minus 15x. I get minus 2x. Together, that is minus 17x. And that's what I want in the middle right here. So that means I did all my work And this third choice of mine is the right answer. So notice every combination is going to give you something different. So there's my answer right there. 5x minus 2, x minus 3. B, I do the exact same thing. How do I get 3x squared? Well, it's 3x and x. How do I get negative 7? So remember, it's a negative, so it's got to be negative 1 and 7. Now this one's not too bad because, remember, it could be 3x minus 1, x plus 7, or it could be 3x minus 7, x plus 1. And actually, I'll change it a little bit, so just so the numbers are the same. We'll say 3x plus 7, x minus 1. Now remember, if I ever get the wrong number but the right sign, the right number but the wrong sign, I'll just flip both signs. And I don't need to do that right now. So I do the outside. 3x times 7 is 21x. I do the inside. It's minus 1x. Together, that's 20x. That's what I want in the middle. So this is the right combination. That's our biggest goal right here, is to figure out which is the right combination. That's it. We've done the whole thing. So we're literally doing everything exactly the same. We're just adding more steps, a little bit more work. So, C, exact same concept. I have 3 terms. The factors of the first term. How do I get 4x squared? Well, it's 2x and 2x, or it's 4x and 1x. So this is the first time we've ever had 2 choices here. So notice, look, I got 2x and 2x, that's an option. 4x and 1x, that's also an option. So you just guess whichever you want to check first. So maybe I want to check 2x and 2x, and I want to check 1 and 5. So I'm going to say 2x plus 1, 2x plus 5. If this works, then I move on. If it doesn't, I try a different combination. I get 10x in the middle. I get 2x in the middle. Together, that's 12x. Now what I want? It is. So, right combination. You don't always guess right the first time. It has to work. If it doesn't work, then you did it wrong. 2n and n. 1 and 3. Now I'm rushing right away. So I'm going to rewind a little bit. Because remember, every time I do this, I go back to my factoring GPS. Whenever I'm lost, I look at the GPS. So, something in common. No, they all don't have a letter. They all don't have a number. So I count the number of terms. 3 terms. 1, 2, 3. That's why I do the factors of the first term first. So in case you're wondering why I jumped right away to do that, I did actually follow my GPS. Now, factors of the last term. How do I get positive 3, 1, and 3? So now I'm going to guess. I could have 2n plus 1, n plus 3. I check the outside. I end up with 6n. I check the inside. I end up with 1n. Together, that equals 7n. That's not what I want. So that's not the right guess. So now I'm going to try 2n plus 3, n plus 1. The outside gives me 2n. The inside gives me 3n. Together, that's 5n. Well, that's not what I want either. And there are no other choices. So even though if there's no choices that work, we still have not factorable as an option. All right, that's going to finish that one. These next few examples, we're going to have 2 terms. Now, all 3 of these are using perfect square trinomials, f and g are using perfect squares. I usually don't use those as patterns as much, but I do use the concept. But E is super easy because E, once again, I'm going to look and find out that there's nothing in common. I count the terms, 2 terms, I hope for perfect squares. If I don't see perfect squares as 2 terms, I did something wrong. So let's see, 9x is 3x and 3x. So 9x squared is a perfect square. 64 is 8 and 8. So it has to begin with perfect square, has to end with a perfect square. Let's get a subtraction sign in the middle. So I say 3x plus 8, 3x minus 8. Done. Now, when I have a trinomial, you could use the perfect square trinomial pattern that we briefly mentioned in the last section. But here's what I do. I say 2y and 2y because it's perfect. Now, I also know that 1y and 4y is also an option. And I have 5 and 5, but I also know that 1 and 25 is an option as well. I always check the perfect squares first. Doesn't mean it's always going to save me time and always going to be right, but I always guess them first. That's what I mean when I see perfect squares that begin and end. So now I check the outside, 10y, the inside, 10y. Together, that's 20y. So that's what I want. See, 20y in the middle. So that's my answer right here. 2y plus 5, 2y plus 5. Now, a lot of times you'll see somebody write that as 2y plus 5 squared. Not always, but a lot of times you will. All right, 30. So G, look, 36. 36 has a whole bunch of factors, but I'm going to start with 6w and 6w because I know it's a perfect square, and I see a perfect square to end. So although there is a whole bunch of other factors for 36, I'm guessing this one first. 6w minus 1, 6w minus 1. I check the outside, minus 6w. I check the inside, minus 6w. Together, it's minus 12w. That's what I want. So this is my correct answer. I will take that one for full credit, but if you do want to write it out as 6w minus 1 squared, I'm totally okay with that. The next ones are all going to focus on factoring out a common term. We did that a little bit before, and we're going to continue to do so. So all three of these are going to have something in common that we're going to take care of first. So like I look at h. H, both of these are divisible by a number. Both of them, 5 goes into both of them. Remember, that's what we talk about pitching in. 5 can only pitch in 5. It doesn't matter that 45 has other factors. So I say the most they can both pitch in is 5. I end with x squared minus 9. Now the problem is whenever somebody takes out a common term, they forget to continue back and follow the GPS. So look, I took out the common term. I still have to count my terms inside the parentheses. And I have two terms, so 1, 2. I'm talking about inside the parentheses. So now I gotta hope that it's a perfect square, which it is. It ends with a perfect square, which it does. It has a minus sign in the middle. So your best answer for h is actually 5, x plus 3, x minus 3. Which you wouldn't have seen if you wouldn't have taken out the common term first, because you wouldn't have seen perfect squares. So all three of these are divisible by 2. So I put 2 outside the parentheses. I end up with 3q squared minus 7q plus 4. So they didn't share a letter, but they all shared a number. So now I do the inside the parentheses just like I've done before. 3q and q. How do I get 4? 1 and 4, 2 and 2. I'm going to say 2. Let's guess. I'm going to guess 3q minus 2. Q minus 2. Let's see if that works. So I'm going to check the outside. The outside is going to become minus 6q. The inside is going to be minus 2q. Together that's minus 8q. That's not what I have here. So that's not the right guess. So I know 2 and 2 is not an option. So now I got to find a different check. I'm going to guess 4 and 1. So I'm going to try 1 and 4. So I'm going to put minus 1, minus 4. I do the outside. I get minus 12q. I do the inside. I get minus 1q. Together it's minus 13q. That's not what I have here. I have minus 7q. So not the right guess. Now remember, when we have, not only does our adding shortcut not work in this section, remember that we actually have a different order matters. You will get a different order whether you put the 4 with the 1q or you put the 4 with the 3q. So I'm going to flip them and see if that changes things. And I do the outside this time, I get minus 3q. I do the inside, I get minus 4q. Together that's minus 7q. So that's my answer right there. So it worked. Notice at that time it did matter. It mattered that the minus 4 was with the 3. So J, look, all three of these are divisible by 3, so I put 3 outside. I have 4p squared minus 7p plus 1. Now I'm going to say it could be 4p and 1p, or 2p and 2p. And the only way to get 1 is 1 and 1. So now I'm going to put 3 outside the parentheses. I'm going to guess. $4p, 1p. I'm going to put minus 1, minus 1. So now this is just a guess. I don't know if it's right. I'm going to check it. I get minus 4p on the outside, minus 1p on the inside. That's minus 5p, so that doesn't work. So now I'm going to try 2p and 2p. And the only reason I didn't change the order this time is because the ones are the same number. So I'm going to try 2p and 2p. I end up with minus 2p, minus 2p. Together it's minus 4p. That's not what I want. So even though this one is not factorable anymore, this is factored a little bit. So that's my final answer. That's all we're going to do today.